Namaste students, myself JV Dr. Monica Trivedi. I'm from Department of Science and Technology, Faculty of Education and Methodology, Jyoti Vidyapeeth, Women's University, Jaipur. Today's topic is metal bonds. So, the isolabile analogy is a theory that relates between the similar organic and inorganic molecule fragments to predict the properties of the organometallic compound. In 1982, Ronald Hoffman described the molecule fragments as the isolabile if the number, symmetry, property, approximate energy and shape of the orbital and the number of electrons in them are similar and not identical but similar. Right? In this diagram, you can see CH3, the D7 metal complex have similar shape and geometry, but they are not identical. The metal bond, the isolabile analogy, other example like CH3 and D7Ml5 are similar, and CH2 and D7Ml4 are similar. CH and D7Ml3 are similar structure, as you can see here in this diagram. The metal another example of metal bond isolabile analogy is according to molecular orbital theory. This is the molecular orbital of CH4, CH3, and CH2. Here is the four 4e electrons, 6e and 8e electrons are present in a p electron and d electrons and for similarly for the DML6, DML3 and DML4 having 18, 17 and 16 electrons. The isolabile molecule fragments can be obtained into the molecule. The fossil, these organic and organometallic fragments can be combined as like CH3, free radical CH3, combine and give the CH3, CH3. Now the metal also combine and give the Ml2CO5. The metal and CH3 combine and give Ml2 MnCO5 CH3. The metal bond. The metal bond. How the metal bond? The organic compound and inorganic compound bind and give the complex. Okay. As the application of the isolabile analogy, it can be described how metal bond is formed. The metal bond can be formed by only using the d orbitals. So bond can make a single, double, triple bond and this kind of bonds. You can see that the CH3 combined with FF and CH2 combined with O double bond. So these are some example organic and inorganic example of a metal bonds. Here you can see carbon carbon bond, fluorine bond, oxygen bond, nitrogen bond, osmium bond, rhenium bond, iron bond, and Mn. These are some example of metal bond. Metal bonds are the modern development of the chemistry of a metal bonded species which is surprised by the crystal structure of Re3Cl2 3 negative and Re2Cl8 negative 2 negative. Especially Re2Cl8 2 negative had a remarkable short metal distance which is 224 pm and was the first complex found to have a quadrupole bond and the general bond length of RE is 248 pm. Here you can see structure of Re3Cl2 and 3 negative and Re2Cl8 2 negative. Multiple bonds of a transition metal is formed by only using d orbital because the molecular orbital is formed when the symmetry property and energy of the orbital is similar. So by the interaction of some d orbitals, MO can appear. In this diagram, you can see for sigma, for pi, and for delta, there are the orbitals which overlap and give the sigma, pi, and sigma, pi, and delta orbitals which are overlap. The metal multiple bond, the d z square orbital of a two metal atom overlap each other, and sigma bond is made. Okay, two dz square overlap and give the sigma. Then d yz and dx orbital of two metal atom overlap with same dy z dx orbital, and these orbital can make two pi bonds. Dx square minus y square dxy orbital, two metal atom overlap with same divisor and dx orbital, and these orbitals can make two delta bonds. In this diagram, you can see here the two delta bonds. The metal multiple bonds in this, the delta bonds are a covalent chemical bonds where four lobes of one involved atomic orbital overlap four lobes of other involved atomic orbital. Okay. This overlap leads to the information of a bonding molecule orbital with the two nodal plane which contain the internuclear axis and go through both atoms. So here you can see the atom A, atom B, they both combine, and the dxy, AOs of dxy and the AOs of dxy will combine, and it will give the delta MOs, the molecule AB. Okay, and this is here you can see the node is present between these overlapping of lobes. Now the metal bond, the first picture described the energy level of a d orbital when metal bonds is formed. The second picture shows the energy level of a d orbital when eight monodentate ligand has bonded to metal bond and formed the M2L8. In this picture, dx square minus y square orbital of a metal which is the strongest overlap with a ligand is formed by MO interaction with eight ligands. Therefore, the quadrupole bond is formed because one of the 5 bonds is stretched by the overlapping with the ligand. And you can see the MO diagram of the M2L8 complex. And you can see that the pi orbital sigma bonding, pi bonding, and sigma anti bonding, sigma pi bonding, and delta bonding for M2L8 complex. Now the experimental explanation is that the difference of the energy between the delta bond and anti-delta bond corresponds to the energy of visible light. So most compounds containing the quadruple bond are widely colored in for the intense light, like Re2Cl8 and 2 negative is a royal blue color, and MO2Cl8 2 negative is a bright red color. So the metal bond, multiple bond having compound show the intense color. But if the additional d electron occupies the delta orbital, reduces the bond order. In case of osmium 2, Cl8 to negative mm bond is a triple bond because the delta bond order is 0 in this compound. And this is the structure of osmium 2 Cl8 to negative complex. Now, here is the sigma pi delta and delta star electrons present in the orbital. The example is MO2HPO4 negative. Okay, and example of bond order is the 3.5 is MO2SO4 3 negative. Example of bond order 4 is MO2SO4 4 negative. So in this compound, the central metal atom is similar, but due to the ligand, the length between the metal bond is different. In a MO2HPO4 2 negative, the metal bond length is 2 to 3 pm, and in a 2SO4 4 3 negative. The metal-metal bond length is 217 pm. In MO2SO4 4 negative, the metal-metal bond is metal-metal bond length is 211 pm. So as you know that the oxidation state changes, the length of the metal-metal bond is differ. Metal-metal multiple bond can have the diamagnetic effect on the bond distance and as measured by the X-ray crystallography. One way to describe the strongest or interaction distance by the metal-metal bond by the comparing both the distance in a multiple bond to the distance of the single bond. The ratio of the these distance is sometimes called a formal shortness ratio. Okay, you can see that C triple bond C and triple bond N. The ratio is 0.783 for C triple bond C and the ratio is 0.786 for N triple bond N. Now here the triple bond in a chromium is the ratio is a 0.767. The metal triple 5 bonds in MO is 0.807 and the four bonds between RE metal it will 0.848. So as the pi bond increases, the metal metal interaction ratio increases. The metal metal multiple bond, and you can see the number of electrons, the formation of metal metal bond, and the oxidation state of the the central metal atom and distance between the metal metal bond. So this is some example in this complexes. As the electron of delta orbital remove, bond length is slightly decreased. A possible explanation for the small change in the bond distance is that the increasing oxidation state of a d orbital. The d orbital is converted, so overlap of a pi bonding become inactivated. So this is all about the metal metal multiple bonds. Thank you very much.